Assalamualaikum warahmatullahi wabarakatuh. We are from Group 4 and today we will be performing the free fall kinematics experiment. So this is the specimen that we use for the experiment, and the scale we have measure. This is 100 millimeter, and this 150 and 200, 250, 300, 350, and the last one is 400. So for the experiment, the specimen will be dropped freely from the measurement, and the time will be set on the timer. Thank you. So we will start with 100 millimeter height. 1, 2, 3. So next is the 150 millimeter. 1, 2, 3. For 200 millimeter. 1, 2, 3. For the 250 millimeters. 1, 2, 3. For the 300 millimeters. 1, 2, 3. For 350 millimeters. 1, 2, 3. For the 400 millimeters. 1, 2, 3. So the experiment will be repeated 3 times for each height to get the average and most accurate time for the experiment. Thank you.
Assalamualaikum and good day. My name is Aidil Adela binti Syafrizan and my metro ID number is MA22119 from Faculty of Technology, Engineering, Mechanical and Automotive. So today, my group and I, which is Group 4, will explain about Lab 9 and the title is Free Fall. As for the introduction, before we know deeply what is free fall, Newton's first law of motion states that while an object is in motion, its acceleration is equal to 0, but its velocity is not equal to 0. Consequently, the object will keep moving in the same direction and at the same speed. So, what is free fall? Free fall is when an object falling freely is one that is falling only because of gravity. An object is said to be in a condition of free fall if the only force acting on it is gravity. When it comes to motion, free-falling objects have 2 key characteristics, which are, first, air resistance does not affect items that are falling freely, and second, when on Earth, the rate of acceleration of all free-falling objects is 9.81 meter per second square. The objective of this experiment is to investigate the kinematic of a free fall from test and to investigate acceleration of gravity speed. That's all from me. I will pass to the next presenter.
Assalamualaikum and a very good evening. My name is Muhammad Aika Daniel. Today I'm going to present about the experiment setup. For the experiment setup, we use a ping pong ball. We use a smartphone for the stopwatch to measure the time for the free fall. And last but not least, a scale height where we can indicate our height for the free fall experiment. Next I'm going to talk about the experiment procedures. First we put 100 millimeter as the fall height. Next, we set the stopwatch and release the ping pong ball to begin the experiment. Calculate the fall time, and enter it in table 1. We repeat 3 times for the experiment at the same height and carry out the experiment at various heights as shown in the table 1. And that's all from me. Thank you.
So for the calculation example, as we know, we have to repeat the experiment 3 times to get the accurate fall time. So from there, we have to get the average time for each height, which is following the formula. The formula is T1 plus T2 plus T3 and divided by 3. Then for the velocity, which is the height over height divided by the average fall time. So the height we collect from this data, which is 100 mm, 150, then convert it to meter to get the velocity in meter per second. For example, this 100 millimeter have to be multiplied by 1000 and then divided by the average for time, and then we get the 0.5556 meter per second. Okay.
As you see that this is the graph between velocity and average time. So we can see that the data that we collect here, the gradient for the graph is increasing when the velocity increase. So the time it will increase and then the gradient will be increased. And next, for the calculation acceleration of gravity AC from the graph. So acceleration can be calculated by dividing the change in velocity measured in meters per second. The time taken for the the time taken for the change in seconds. This value can get from the graph by using slope method. The calculation shows as below. Acceleration of gravity is equal to AC, where 1.1667 minus 0.556 divided by 0.3 minus 0.18 and then times 2, and we can sum the result is 10.185 meter per second square.
We are going to look on the discussion for our lab 9. Why there are some differences between experimental gravity acceleration with accepted gravity acceleration. Two factors is air resistance and experimental errors. Air resistance is presence of air causes resistance in free fall. Impact observed gravity leading to derivations from ideally 9.81 meter per second. For experimental errors, it incur accuracies in measurement. Errors during experiment led to variation in gravity acceleration reading. A free fall experiment measures gravity acceleration may differ from the accepted 9.81 meter per second due to air resistance, experimental errors, initial condition variation, local gravity differences, equipment calibration issues, and unaccounted external forces. Now let's look on question number 2. From table 1, the data, what is relationship between the fall height and the average of velocity? From table 1, we can understand that the higher the height of ball drop, the faster the velocity. It shows that the height is directly proportional to the average velocity. Next, we will go to the third question. Third question is, in your opinion, what will happen to acceleration if we change the steel ball, or can be known as a ping pong ball, diameter 50 millimeter to diameter 20 millimeter, and explain why. First, if we increase the ping pong diameter, it will reduce the ping pong acceleration. Thus, the surface impact will have a larger diameter, increases the ping pong surface area. The surface area affects acceleration due to air resistance. With this, the effect of falling ping pong, as the ping pong falls, acceleration decreases. Diameter, surface area, and air resistance increases. With this, the radius increase and acceleration also decreases. From this, we can understand that from the equation description, G is constant, mass and radius is inversely proportional to gravity and acceleration.
And conclusion, what we have learned? We learned two things, which is free fall conclusion and velocity proportional to height. Free fall occurs when only gravity acts on an object. Gravity is the sole force influencing the object's motion during free fall. For velocity proportional to height, object's velocity is directly proportional to its height while falling. Decreasing height leads to shorter fall time and increases velocity. That's all from me. Thank you.